Hi everyone! Today we'll take a closer look at Chapter 4, Test Analysis and Design. We will learn the section Boundary Value Analysis in the topic Black Box Test Techniques. Let's begin. This video is a part of the ISTQB Foundation Level Preparation course on Udemy. For more information, check the description below the video. We will find out what study materials we can use for self-study. Also, together with you, we'll find the correct answers to several ISTQB questions with the help of the theory. And at the end of the video, we'll discuss a problem that worries a lot of students. In some questions, it's completely unclear why negative boundary values are ignored or, conversely, not ignored. Let's begin with study materials. At first glance, boundary value analysis is a simple test design technique. But when it comes to the questions of ISTQB, they are also so complicated that even artificial intelligence does not know what to do with them. As you can see, we asked the AI a question, one of the simplest ISTQB questions of the BVA. And we got an answer, that the correct answer is either C or D. So, all warnings that AI is smarter than humans and that it can leave us without a job were in vain. No, unfortunately, we don't know if this is true or not, and only time will tell. But we clarified that only one answer is correct, and the AI was able to find the correct answer. So we started to worry again. And we asked a clarifying question. Why answer option D is incorrect? After processing the information, the AI changed its mind, decided that the answer option D is still correct, and returned to the fact that there is not one correct answer, but two. We insisted on our claim that there is only one right answer. And so, sooner or later, AI did say that only option C is correct, and gave an explanation. To be honest, the explanation is not very meaningful and correct. Accordingly, we decided not to torment the AI anymore and thanked it. AI told us to ask questions if there were any, and we have one question left. We asked the very first question again, to test whether the AI learned or actually understood the BVA test design technique. As you can see, the artificial intelligence still finds two correct answers. Accordingly, we have one conclusion. We don't know if AI is smarter than we are, probably it is. But AI won't help us yet to prepare for the ISTQB exam. It's as confused as we are, or even more. Therefore, let's try to understand this seemingly simple topic, with which even artificial intelligence has many difficulties. To begin with, we should familiarize ourselves with the theory of the application of boundary values analysis. And the latest version of the syllabus should help us with this. Unfortunately, the syllabus is written very abstractly without examples and additional explanations which are necessary for the questions of the K3 level. That is why we created this video to give you additional explanations on how to apply the technique in practice. However, we will still start with self-studying. In addition, we advise you to read the same section in the previous version of the syllabus version 3.1. It has several examples with explanations of the test design technique. Additionally, you can read information about the BVA in the book Foundations of Software Testing ISTQB Certification by Rex Black. This is one of the authors of the exam, and his explanations will be very helpful. Within this thread, it doesn't matter which version of the book you find, 3rd edition or 4th edition, both have valid information. The problem is that the books are not freely available and they are quite expensive. But maybe they are available for your organization, or you might be lucky enough to find at least the 2011 edition. Now, let's learn how you can use the theory written in the syllabus in practice. You can pause the video and familiarize yourself with the content of the slide. We presented the theory of the syllabus in a logical sequence of actions that must be done in the simplest test on BVA. There are 3 or 4 steps, depending on whether you use 2-value or 3-value BVA. Let's check how the theory works in practice. Let's say we have such a question, very simple. The password length is correct if it has between 6 and 12 characters inclusive. Otherwise, it's considered incorrect. and we need to use 2-point boundary values. Let's find the answer to this question. In most cases, when they explain the boundary value analysis test design technique, they say that everything is very easy. We start with equivalence partitions, which we have already studied. Sometimes 3 partitions are allocated and sometimes 1. For example, 1 valid partition, 6 to 12 special characters. The next step is to define boundary values. The minimum and maximum values, or first and last values, of a partition are its boundary values. In our case, 6 and 12 are boundary values. Again, everything seems obvious and goes smoothly, and we can move to the last step. For each boundary value, there are 2 coverage items. This boundary value and its closest neighbor belonging to the adjacent partition. And here everything is obvious as well. 6 and 12 are boundary values. 5 and 13 are boundary values closest neighbors. As a result, we have 4 values. And the answer option A has exactly those 4 values. It seems that this test technique is much easier than equivalence partitioning. And it's not clear why artificial intelligence has problems with it. Let's take the last step and everything will become clearer. Most students have problems with 3-point boundary values, and at first glance everything is simple and clear. The first 3 steps are the same as with 2 values BVA, and we have already passed them and are moving to the last step. For each boundary value, there are 3 coverage items, this boundary value and both its neighbors. When we use 2 BVA values, we selected only one neighbor of the boundary value. This time we need to select values not on either side of the boundary values. The result is 2 additional values, 7 and 11. 6 BVA in total. Option B has exactly these 6 values. Everything looks simple and clear, and it seems that it will be an easy point on the exam. However, answer option B is incorrect. In fact, there are not 6 boundary values, but 8. And at this point, most students get lost and don't understand where a mistake could have been made in such a simple theory. How the values 4 and 14 are also boundary values is unclear, and it seems wrong. Those who know where we made a mistake may not watch the rest of the video. Most likely they understand the theory perfectly. Those for whom it's not clear why the values 4 and 14 are limit values, we invite you to our complex and twisted explanation of the theory of BVA. In fact, there is only one nuance that you need to understand, and then you will easily solve questions from BVA. But we need to start from the beginning. Same question, and we have to use 2-point boundary values. Our first and main mistake was incorrectly defining equivalence partitions. Let's define them step by step for better illustration. And we start with a valid partition. We have already performed this task more than once. Everything is simple here. Let's move on to the next step. The next step is to define 2 invalid equivalence partitions for numeric values. BVA can only be used for ordered partitions. Therefore, we can always identify 2 invalid partitions. In our case, these values are 5 and less and 13 and more. Now we need to define the boundary values. The minimum and maximum values, or first and last values, of a partition are its boundary values. This is a small but critical change. As you can see, we have not 1 partition but 3 partitions. Accordingly, each can have 2 boundary values. We do not know the minimum value of a first partition and the maximum value of the third. Therefore, we do not have 6 boundary values but 4. The next step is, for each boundary value, there are 2 coverage items. This boundary value and its closest neighbor belonging to the adjacent partition. And this is where the main difference arises, which is not written about in textbooks or syllabus. The fact is that the boundary value is the value within the partitions. It's very confusing and unclear, so most people try to avoid this topic. But we will not, and will try to illustrate the point. When you use 2-point BVA, then you have to define 2 values. It is the limiting value of its nearest neighbor. Accordingly, if we want to test the boundary value 5, then we must test 5 and 6, so it is not obvious, twisted and confusing, and most avoid explaining this point. But it's important to understand because it has key knowledge for the future 3-point BVA. Accordingly, for the boundary values of 6 and 12, the neighbors are 5 and 13. And for the boundary value 13, the neighbor is the value 12. And thus the complete table looks like this. Each boundary value has one neighbor, and a total of 4 neighbors. Most try to avoid this explanation because it takes additional steps, but in the case of 2-point boundary analysis, it does not bring any result. As you can see, the neighbors on the left, 5 and 12, are the same as maximum boundary values. Therefore, they can be ignored. The same situation with the neighbors on the right. 6 and 13 are the minimum boundary values of the second and third partitions. Therefore, we have only 4 unique values that correspond to the boundary values of all 3 partitions. Accordingly, when using the 2-point boundary value analysis, the neighbors of the boundary values of one partition will always be the boundary values of the adjacent partition. That is why most of these steps are ignored and not explained. After all, we have additional confusions and twists, but the result is the same as we would ignore all these steps. When using the 2-point boundary value analysis, you have the choice to either use a simple explanation or a complex one. In our opinion, a complex explanation is better, because using it, you will better define equivalence classes and boundary values. And the expediency of a complex explanation is best illustrated with the help of a 3-point BVA. Let's check the theory using the example of this very question. In the scope of the 3-value BVA, for each boundary value there are 3 coverage items, thus boundary value and both its neighbors. We have already done most of the work. We defined the boundary values and one neighbor for each. Now it remains for us to determine what is next to our neighbor on the other side. The best way to do it is to define neighbors of boundary values per partition. Thus, for the first invalid partition, we have only one boundary value, 5, and its neighbors are values 4 and 6. For the second partition, which is valid, we have 2 boundary values, 6 and 12, and neighbors are values 5 and 7 for minimum boundary value, and 11 and 13 for maximum boundary value. For the third partition, we have only one boundary value, 13, and its neighbors are 12 and 14. So the complete table looks like this. We have 4 boundary values, and each of them has 2 neighbors. Some neighbors are also boundary values, and some neighbors are not boundary values. And this is our last step, to define a unique set of values. The easiest way is to write out all the values that are on our line. All 8 of them are 3-value BVA coverage items. But in this case, it's very important that the values on the line are defined using the table. Otherwise, some values may be missed as happened in our first explanation. Another option is to go through the values of the table from the smallest to the largest. Then, when the value is both a boundary value and a neighbor, we record it on the table only once. In our case, this value is 5, 6, 12, and 13. And the full table looks like this, 8 unique values. As we said, this technique is simple only at first glance. In fact, with all the theoretical nuances, BVA is very complex. After all, it has the same problems as equivalence partitioning, but it also has its own complex characteristics. As you can see, this time it is clear why answer option B is incorrect. It ignores the values 4 and 14, which are the neighbors of invalid boundary values. That's all. We discussed all the theoretical and practical aspects of applying the BVA task design technique. We hope that it's now clear to you and that it will be easier to answer ISTQB questions and also to use it in practice. We know that at this moment, most likely, you're even more confused than before this explanation. Let's try to use what we have learned about the BVA test technique in the example of questions from the official ISTQB exam samples, and maybe everything will become clearer for you. There is a 100% chance of having one question of K3 level on the exam ticket. The K3 level questions are the most difficult. Some you can answer in 1 or 3 minutes, but some questions are so twisted and confusing that you can spend 10 or more minutes on them. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the question themselves can pause the video. Let's find the answer to it in the study materials. Our basic approach is to go through all the necessary steps to apply the BVA test technique. And we need to start with reading the description of the question very carefully and try to find information there and that can affect the basic approach. Let's check the question one more time. As we can see, there are no specific conditions. We see that it will be necessary to apply a 3-value BVA. Also, our variable is password length. The boundary values of valid equivalence partition are simple and clear, but invalid partitions are confusing. First of all, we write down everything related to the password length variable. The password length is correct if it has between 6 and 12 characters inclusive. At first, the form is empty, password length equals 0. And let's move on to the first step of applying the BVA test technique. Definition of valid and invalid equivalence partitions. Based on the first sentence, the password length is correct if it has between 6 and 12 characters inclusive. We can define 3 equivalence partitions, 1 valid and 2 invalid. But the second sentence is quite confusing. At first, the form is empty, password length equals 0. Based on it, we know that 0 is the minimum value of the first invalid partition. But this raises the question of whether we need to define another invalid equivalence partition where the value is less than 0. We'll get back to that in a minute. So, the equivalence partitions are defined. Now it's time to define the boundary values. Each equivalence partition has 2 boundary values, a minimum and a maximum. And we can only identify 5 according to the question description. 0 and 5 for the first partition, 6 and 12 for the second partition. But only the minimum value for the third partition, 13. The maximum value is not specified in the question description. Let's move on to the next step, defining neighbors, boundary values. We wet with 2-point BVA. Accordingly, each boundary value will have only one neighbor, its closest neighbor belonging to the adjacent partition. And this is where the problem arises. We see that the nearest neighbor to the value 0 is the value -1. The question description should describe some details that should help us decide whether -1 is the value we write as a neighbor or not. But there is no information in the description of the question that would help us with this. In such cases, we have no better advice than to rely on our gut feeling. Since we are not on the exam now, but on the tutorial, we can take a look at the hint. And as we see, in the explanation of the question, there is no information about why exactly -1 is not a neighbor. This value is simply ignored. In our opinion, it is ignored because it is physically impossible to enter the number of characters less than 0. However, we can enter 1 character and try to delete 2 characters. Of course, it's debatable whether to count this as a -1 value. But the problem here is different. We don't have enough information to know if -1 is a 2-point, 3-point boundary value or not. And unfortunately, we have no advice for you on how to understand it, besides relying on our gut feeling. The good news is that we haven't come across such controversial questions on the actual exam yet. In most cases, it's easier and more obvious to determine the boundary values on the exam. And let's go back to our question. Let's imagine that our inner feeling told us correctly, and we understood that it's not necessary to test the value -1 because it's physically impossible to enter a value less than a 0. The rest of the boundary values are very easy to determine. These values are 5, 12, and 13. The next step is to define the coverage items. To achieve 100% coverage with 2-value BVA, test cases must exercise all coverage items, all identified boundary values. As we said earlier, the 2-point BVA, all boundary values and their neighbors are the same. That's why we get only 5 tests. 1 test for each boundary value. But our task does not end there, according to the question description. Our set of test cases achieves 100% 2-value BVA coverage. the team decided that due to the high risk of this component, test cases should be added to ensure 100% three-value BVA coverage. So we need to determine the three-value BVA. For each boundary value, there are three coverage items, this boundary value and both its neighbors. We have already defined our neighbor within the scope of application of two-value BVA. It remains for us to determine one more neighbor on the other side. For the first partition, from 0 to 5, these will be the values 1 and 4. For the other two partitions, we have already defined neighbors in our tutorial. These values are 7, 11, and 14. And the full table of values will look like this. 5 boundary values for two-value BVA and then 10 boundary values for three-value BVA. Now, according to the description of the question, we have to exclude tests that are already covered by 2 or more BVA. That is, these 5 values 0, 5, 6, 12, and 13. And we have only 5 values related to the three-value BVA. 1, 4, 7, 11, 14. This is the answer option D. And as you can see, the most difficult point is the definition of the minimum and maximum boundary values and their neighbors. Those who have not encountered these questions yet may think that we exaggerate the problem, and after all, it's obvious that a person cannot enter less than 0 special characters in the password field. In fact, this is one of the most controversial issues, because some instructors and exam providers define negative values and values that exceed the maximum possible as boundary values, and other instructors and providers don't. For example, ISTQB, which is the official United States country board for ISTQB software tester certification. In their questions devoted to the BVA test design technique, negative and over maximum values are almost always defined as boundary values. For example, this is a question where there is weight and price of delivery. Obviously, a negative weight is the same as the real number and a negative number of special characters. But as we can see in this question, -1 is also a boundary value. As we said, unfortunately, we have no advice for you on how to understand it, besides relying on your gut feeling. If your variables are temperature, price, or weight, you most likely need to include negative values as boundary values, but sometimes you have variables that are ambiguous. For example, points. Let's check this controversial question example, which is very popular. Those who want to try to answer the question themselves can pause the video. Let's find the answer to it in the study materials. Our basic approach is to go through all the necessary steps to apply the BVA test technique. And we need to start with reading the description of the question very carefully and try to find information there that can affect the basic approach. Let's check the question one more time. Again, there is no information in the description of the question that would affect the application of the BVA technique. We see that we have to use two-value boundary value analysis, that's all. So we strike out the part from the three-value BVA, and we start with first step, definition of valid partitions. Our variable is the final grade, and there are 6 grades. Drawing the axis of variables and determining valid partitions is not a problem. The problem occurs again in the second step. Definition of invalid equivalence partitions. There must be at least 2 partitions, unless otherwise specified in the question description. Accordingly, we can define invalid values from -1 and less, and from 101 and more. What your sixth sense tells you? Should we define 2 negative equivalence partitions or not? Or maybe only 1 negative, as in the previous case? 101 points or more? To be honest, our sixth sense is asleep. From a theoretical point of view, we must define 2 equivalent classes. Given the experience of the previous question, only 1, 101 and above. But it may also be that it's impossible to get a score other than from 0 to 100. There is not enough information in the question description to understand this. Again, since we are not in the exam, we can look at the cheat sheet and see that for some reason that is not clear for us, neither -1 nor 101 are boundary values. Again, many will say that we are exaggerating the problem and that it's obvious that score cannot be 101 or much less -1. But we'll return to the American Association again and show that we are not the only ones confused. As you can see, the question has changed a little. In order not to confuse students, the American Association started not with -1 but with 0. But it also defined 101 as the boundary value. So who do we think is right? Should 101 value be the boundary value or not? We believe that this should be written in the description of the question. There should be additional sentences that should explain that other values are not possible or that it is possible to score more points. As we mentioned earlier, the good news is that we haven't come across such controversial questions on the actual exam yet. In most cases, it's easier and more obvious to determine the boundary values on the exam. And if you come across such a question, then you can only guess because it's still difficult to notice any obvious system. Now, after checking the cheat sheet, we know that we have to cover only these values, and these are the only equivalence partitions. We need to create a full table with boundary values and their neighbors. After all, there is a lower probability of making a mistake. Accordingly, the full table of values will look like this: -1 and 101, which are neighbors of the values 0 and 100, respectively, for some reason are not included in the table. Next, we create a table with test cases and consecutively write down all the values which we defined, 0, 50, 51, and so on. Until we write down all the boundary values and their neighbors, as we used two-value BVA, all the test cases will be boundary values, those which are defined on the line. Next, we copy the table from the question, where we have 6 test cases. And we will fill the table with test cases. The first test case covers with the 9th boundary value. Second test case covers the second, and so on. In total, we have 6 test cases and 12 boundary values. The test cases are unique and valid, so only 6 boundary values are covered. BVA coverage is measured as the number of boundary values that were exercised, divided by the total number of identified boundary values, and is expressed as a percentage. 6 divided by 12 and multiplied by 100 equals 50%. Accordingly, answer option A is the correct answer option. And again, the most difficult point is determining the minimum and maximum values. There are variables such as temperature, fonts, weight, which are more obvious and can be negative or exceed the maximum permissible values. It's easier with such variables, but there are variables such as score points, char lengths, speed, with which everything is not so obvious, and in our opinion, there should be additional details in the description of the question to avoid confusion. Let's check another example of the ISTQB question. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the question themselves can pause the video. This example with the temperature variable nicely illustrates that when the variable is obvious, then the BVA question is quite simple. As usual, we start by carefully reading the description of the question and looking for information that can affect the general approach to the application of the BVA test design technique. Unlike equivalence partitioning, BVA questions rarely contain relevant information. For the most part, this is purely information about the variable and whether we should use 2-value BVA or 3-value BVA. So in our case, we cross out everything related to the 3-value BVA, and we start with the first step of defining equivalence partitions. This time, everything is easier. We have a very clear and understandable description. If the temperature is between 0 and 2 degrees inclusive, the system displays the message temperature OK. For lower temperatures, the system displays the message temperature too low, and for higher temperatures it displays the message temperature too high. Accordingly, we define 3 equivalence partitions, 1 valid and 2 invalid. The next step is to highlight the boundary values. Again, nothing special. We have 4 boundary values, -1, 0, 2, and 3. This time, we will not separate adjacent values. After all, with a 2-value analysis and such a simple question description, they will repeat the already defined boundary values. The correct option is answer option C. As you can see, the questions related to the BVA test technique can be very simple. Difficulties arise only with questions where the conditions for defining negative equivalence partitions, boundary values, and neighboring values are not fully understood. As you probably already understood, it's difficult to give any advice because for two virtually identical questions, the boundary values are determined differently. In one question, the value 101 is a boundary value, and in the other, it's not. In the explanations for the solutions to the questions, we also do not have any valid information that could help us understand why the value of 101 is not a negative boundary value, and we can only give obvious advice. If your variables are temperature, money, or something similar, you most likely need to include negative values as boundary values. If your variables are not so obvious, something like points, speed kilometer per hour, weight, then you only have to rely on your sixth sense and hope for luck. As we have emphasized more than once in this video, we haven't come across such controversial questions on the actual exam yet. In most cases, it's easier and more obvious to determine the boundary values on the exam. The questions are mostly like this, where you have 4 or 5 equivalence partitions, and you have to find which answer options covers the largest number of boundary values. Mostly controversial and ambiguous values such as -1 are avoided, but a value that is 1 or 2 more than the maximum is almost always a boundary value. Unlike equivalence partitioning, BVA questions rarely contain relevant information. For the most part, this is purely information about the variable and whether we should use 2-value BVA or 3-value BVA. In any case, the checklist helps not to forget the basic rules of using the boundary value analysis test design technique. For the topic black box test techniques, we have about 50 questions in total. About 10 of them will be related to the section boundary value analysis, and it is more than enough for practice. Well, that's the end of today's tutorial, and we hope to see you in the next lecture.